But in truth, today's atmospheric CO₂ concentration is very low. For instance, I learned from my time here at the CO₂ Coalition that at CO₂ concentrations below 150 parts per million, plants starts to die of CO₂ starvation, and so our current value is actually very low.
This is Climate Debrief, brought to you by the CO₂ Coalition. I'm Angela Weir. In a few moments, I'll be taking you through a presentation with Dr. Frits Byron Soepyan. Dr. Soepyan earned dual Bachelor of Science degrees in Chemical Engineering and Mathematics from the University of Tulsa in 2009, followed by a PhD in Chemical Engineering in 2015. As a PhD student, he developed TU-Storm for Chevron, a program enhancing sand transport and pipelines that has been used in major capital projects. He later worked as a postdoctoral research associate at NETL on carbon capture systems, energy projects, and improvements to the in-house Focus software. Then as a process systems engineer at Aristasys on emission reduction, decarbonization, and hydrogen production. After examining the benefits of CO₂ and the risks of net zero, Dr. Soepyan joined the CO₂ Coalition, where he now serves as Science and Research Associate. It's great to have you on Climate Debrief, Dr. Soepyan.
Thank you, Angela. I'm happy to be here, and thank you for inviting me.
Given your background in chemical engineering and your work analyzing carbon dioxide and climate through long-term observational data with the CO₂ Coalition, what first drew you to examining these issues through the deep historical and geological record?
So what drew me is initially, as you mentioned in your introduction, I worked on projects involving CO₂ capture, and then one day while looking through the news at LifeSite News, I discovered about the CO₂ Coalition and its publication in 2023, this was back in 2023, of Challenging Net Zero with Science, which was prepared by Dr. William Happer, Dr. Richard Linson, and Gregory Wrightstone. And I looked through that report and I found out about the benefits of CO₂, which I never even thought about. And so I decided to investigate about further about the benefits of CO₂ on plants, and I found out about the works of Dr. Sherwood Itso, who was also featured in the Challenging Net Zero with Science report. And I found out about how CO₂ helps plants grow and produce more food, produce more fruits, and which again we will talk about. I'll discuss that later in further details. But then, and when I started working for the CO₂ Coalition, I eventually looked at data, and then thanks to Gregory Wrightstone, I received recommendations that where we need to look at data and the long term data to better understand what's going on with CO₂. So in summary, the issues regarding CO₂ and the climate and how it affects the climate needs further investigation.
Why do you say modern CO₂ levels are actually quite low and even dangerously close to the minimum needed for plant life?
All right, so for instance, if we were to look only at this slide and the information on this slide, we could see that the atmospheric CO₂ concentration has increased from about 280 parts per million at 1750, which is the start of the Industrial Revolution, to over 400 parts per million in recent years. And it looks high. I mean, we have approximately 50% increase in atmospheric CO₂ concentration. And people, when they see this, they get worried. But in truth, today's atmospheric CO₂ concentration is very low. For instance, I learned from my time here at the CO₂ Coalition that at CO₂ concentrations below 150 parts per million, plants starts to die of CO₂ starvation, and so our current value is actually very low. 150 parts per million is equivalent to 0.015%. Meanwhile, our CO2 concentration today of about 430 parts per million is equal to 0.043%, and that is an indication of how low today's CO2 concentration is. And furthermore, if we were to look at a longer geological time scale, we could see that today's CO2 concentration, or CO2 concentration in recent years, shown in the blue curve in the lower right-hand corner, is actually very low when you compare that to this atmospheric CO2 concentration over the past 400 plus million years. So basically this chart shows the atmospheric CO2 concentration on the y-axis, and on the left side, the x-axis is on the scale of million years before the present, and on the right side, the x-axis is in the scale of year, in the scale of year. And the black dashed line shows the 150 parts per million minimum for plant life. And we can see that based on this chart, there were times in the geological past, hundreds of millions of years ago, there were times when the atmospheric CO2 concentration came dangerously close to this lower limit for plant life. And likewise, at the beginning of the Industrial Revolution, at the atmospheric CO2 concentration of 280 parts per million, we also came very dangerously close to this lower limit for plant life. And therefore, the recent rise in atmospheric CO2 concentration is actually a positive development rather than something to be feared. And plants are thankful for that.
These images show pine trees growing dramatically larger with higher CO2, satellite evidence of global greening, and the large gap between outdoor and typical indoor concentrations. How do these three pieces of evidence change the way we should think about rising atmospheric CO2?
So as I mentioned previously, plants are thankful for the increase in the recent increase in atmospheric CO2 concentration, and these images show that. And these images show Dr. Sherwood Itso standing next to four different pine trees, each grown at different CO2 concentrations. And this image actually also comes from the Challenging Science report. And these images show that at higher CO2 concentrations, the pine tree grows bigger and taller, which means that CO2 is beneficial for the growth of plants rather than being detrimental. And so increased CO2 concentration is actually, as I mentioned, a positive development rather than something to be feared. And if we want to look at the big picture, map right here, taken from a research article by Gutierrez, Hernandez, and Garcia, published in 2025, shows the normalized difference vegetation index. So it's basically a quantity that shows how green the Earth is. And the trend, it starts at 1982 and ends at 2023. And the map shows that multiple areas around the world, including Europe, China, India, as well as various parts of Latin America and eastern parts of the United States and Indonesia, are experiencing greening, which means that vegetation is actually getting healthier in those regions rather than getting worse. So, and NASA has also attributed 70% of this development of greening, or the increase in vegetation, to increased CO2 concentrations, or to CO2. I mean, CO2 is credited for 70% of this greening by NASA. As far as effects on humans, basically this table shows the typical, or the CO2 concentrations that we could be exposed to in various circumstances. So for instance, in the first row, we have the average atmospheric concentration of nearly 430 parts per million in the year 2025. That value, when you compare that to indoor CO2 concentrations, they're actually very low. For instance, in elevators and large conference rooms, we can have about 50% more CO2 concentration, and the atmospheric and the CO2 concentration in various places like submarines and airplane cabins can be 5,000 parts per million or higher. and yet people are still doing fine. I mean, our sailors are doing fine in submarines, and whenever we fly, we're also doing fine. We're not feeling faint or anything. And so the our current increased atmospheric CO2 concentration is not endangering humans. In fact, the CO2 concentration only becomes dangerous at concentrations of above 10,000 parts per million, which is, let's say, about 25 times higher than the current value. So as I mentioned, our recent increase in atmospheric CO2 concentration is nothing to be worried about.
Across the slides in this section showing worldwide temperatures, the Central England record, Greenland ice cores, and hundreds of millions of years of data, what consistent pattern emerges about the relationship between temperature and CO2?
Again, so now that we've talked about the benefits of CO2 and how the increase in the atmospheric CO2 concentration is not endangering humans, let's talk about the big topics. So the big topic is, of course, how CO2 affects temperatures. So basically this chart shows the worldwide average temperature anomaly relative to the 1961 to 1990 average on the y-axis, and the x-axis shows the year, and the secondary y-axis shown in blue shows the atmospheric CO2 concentration, and the blue curve on the graph shows the atmospheric CO2 concentration, and the red curve shows the temperature anomaly, and the dashed black line shows the 5-year average. And basically what this graph shows is that from the late 1800s to the early 1900s, we have a decreasing trend in temperature despite the increase in atmospheric CO2 concentration. Similarly, let's say from the 1940s to the 1970s, there was also a decrease in temperature despite the increase in atmospheric CO2 concentration. As a matter of fact, it was also during this time period when we have newscasters, including Walter Cronkite, as well as celebrities, including Leonard Nimoy, talking about the incoming ice age. So rather than being worried about global warming, back then they were worried about global cooling and how we are in danger of approaching the next ice age, which we all know that did not happen. And so the fact that we have cooling periods in the temperatures despite the increasing atmospheric CO2 concentration suggests that CO2, while it does affect the temperature while playing a minuscule role, but it's not the only factor that affects Earth's temperature. There are a lot of other factors that affect Earth's temperature, including the tilt of Earth's, the Milankovitch cycle, including how the Earth's orbit around the sun is elliptical, the tilt of Earth's axis, and how the Earth spins around the sun, as well as solar activities, which again are beyond our control. And as well as there are other activities also, which I will talk later on in this podcast, which is El Nino and La Nina cycles, for example, oceanic currents and oceanic cycles that also affect our temperatures. So if we were to look at a longer temperature record, so instead of just the past 100 years or so, we look at the past 400 years or so. So I'm basically on this slide, I'm showing the Central England average temperature from the year 1659 to 2025. And what's so special about these temperature data is the fact that it is one of the longest, if not the longest, instrumental temperature record that we have available. And once again, similar to the previous chart, the y-axis shows the temperature in red. The second y-axis in blue shows the atmospheric CO2 concentration, and the x-axis shows the year. And the blue curve shows the atmospheric CO2 concentration. The red curve shows the temperature, and the black dashed line shows the 5-year average of the temperature. And based on these data, we see that from the late 1600s to about the mid 1700s, we see an increase in temperature in central England, despite the fact that the atmospheric CO2 concentration remains fairly constant and at about a value of about 180 parts per million, which is about 50% lower than today's value. So the fact that the CO2 remains flat during this time while the temperature increases, again, further shows that CO2 is not the only factor that affects Earth's temperature. And I'd also like to add that this increase in temperature that occurred from the late 1600s to the mid 1700s also could serve as a foreshadowing to the warming that we're experiencing today, which is a recovery from a cold period known as the Little Ice Age. Okay, so as I mentioned, I talked about the Little Ice Age. So basically this chart again shows similar information as the previous two slides, but the time span has now been expanded to 4,000 years. So once again, the y-axis shows the temperature as well as the red curve. The secondary y-axis in blue shows the CO2 concentration, and also the blue curve shows the CO2 concentration, and the x-axis shows the year. And basically what this chart shows is that temperature has always been fluctuating, and yet the atmospheric CO2 concentration for thousands of years at one point remained fairly constant at about, well, fluctuating also, but remains fairly constant at about 180 parts per million, which is about 50% lower than today's value. Yet despite that, we see temperatures going up and down, which again further shows that multiple factors other than CO2 affects our Earth's temperature. And I'd also like to point out that the current warming that we're experiencing is nothing to be concerned about because, well, yes, while we are warming, there were time periods in the past when the temperature was warmer, and yet during these time periods, rather than suffering, people are actually thriving because it was during these time periods when agriculture was thriving and civilizations thrived, and it was during cold periods that civilizations crumbled. And so warm climate actually brings prosperity rather than demise, and cold climate brings demise rather than prosperity. And so the current warming that we experience since we recover from the cold period known as the Little Ice Age, shown also on this chart, is actually a positive development, just like the increase in atmospheric CO2 concentration. So just like with the atmospheric CO2 concentration data, I'm also going to do similar analysis with the temperature data, where we're going to show temperatures going back hundreds of millions of years. So this chart shows the atmospheric CO2 concentration on the y-axis, on the first y-axis in blue, and the curve for the CO2 concentration is shown in blue on this chart. And the secondary y-axis shows the temperature in red, and the red curve shows the Earth's temperature. And the x-axis shows the time in millions of years before the present. And basically what this chart shows is that there were time periods in the past when the atmospheric CO2 concentration is falling, yet the temperature is increasing, such as during the Devonian era, as well as, and in the beginning of the Triassic era, we see an increase and a decrease in temperature, but then the CO2 concentration decreased and increased, so the opposite trends. And likewise, we also see that, for example, in the Tertiary period, when there was an increase in atmospheric CO2 concentration, yet the temperature also decreased, and which again is an indication of how CO2 is not the only factor affecting the temperature.
Now we'll cover everything from cold-related deaths to lengthening growing seasons in the U.S. and Arctic, rising cereal yields, and global food production outpacing population growth. Taken together, what do they tell us about the real-world effects of the modest warming we've seen?
So, thank you, Angela. So as I mentioned previously, civilizations thrive during warm periods and crumble during cold periods. And we still see that pattern today. For example, this chart shows data presented by Zhao et al. In their 2021 paper. And the data show that the number of people, or the percentage of people who died from the cold far exceeds the percentage of people who died from the heat during the time period of 2000 and 2019, so in the past 2 decades, in other words. So therefore, a warming climate is actually beneficial for us, as it could prevent it could prevent and reduce cold-related deaths. Now, in terms of agriculture, so in terms of agriculture, so the modest warming that we are experiencing is actually also beneficial for agriculture, as it extends the length of the crop growing season, which means farmers have more opportunities for planting and for harvesting, which means more food production for all of us. And this map basically shows how the growing season has lengthened around the world, where green shows a lengthening and red shows a shortening. And in most parts, in multiple parts around the world, including especially Scandinavia here and also central North China and Central Asia, we see a significant amount of lengthening of the growing season. And then this map here shows a close-up of the Arctic region, and similar to the two regions I mentioned previously, the Arctic region also is the benefit of a lengthening of a longer growing season, where in this map the color green represents a lengthening of the growing season, while the darker color of red and brown shows a shortening of the growing season. And we see again multiple parts experiencing longer crop growing season, including Scandinavia and northern Russia and eastern Russia, as well as Alaska and northern Canada. And finally, for the United States, this chart right here shows how the crop growing season has grown. So the y-axis shows the deviation of the length of the crop growing season in terms of number of days from the long-term average, and the x-axis shows the year. And this chart shows that since 1895 to the 2020s, we've had an extension of the crop growing season by nearly 2 weeks, which is, again, as I mentioned, a good thing, a positive development for farmers, as it allows them more time for more plantings and harvesting. So speaking of harvests, this chart here shows the crop yield data for the 4 most produced cereals during 2010 to 2024. And these data are obtained from the United Nations Food and Agricultural Organization, or UN's FAO. And in each of the y-axis of these 4 charts, we have the crop yield shown in black, and as well as the black curve. And we have the atmospheric CO2 concentration shown on the secondary y-axis in blue, and the blue curve shows the atmospheric CO2 concentration. And the x-axis of these charts show the year. And basically what these charts show is that the crop yield has been increasing over the past several decades, and it coincides with the atmospheric CO2 concentration. And again, that's no coincidence, as the increase in the atmospheric CO2 concentration is a contributor to these increasing crop yields, in addition to agricultural innovation, as well as the modest warming that we're experiencing and the use of nitrogen-based fertilizers produced from fossil fuels. So instead of decaying, we see that agriculture is actually thriving around the world. And continuing on this subject, so this chart right here shows data from OECD, which shows that from 1800 to about 2020, we see that population has been increasing, and likewise, but the total agricultural land use has remained fairly constant from 1960 to 2020, yet despite that, the worldwide food production has outpaced the population growth, despite the land use being fairly constant. So this is again credited to increased yield and increased crop yields, which is credited, as I mentioned, to increase in the atmospheric CO2 concentration, the modest warming that we're increasing, as well as agricultural innovation and the use of fertilizers produced from fossil fuels.
This concludes the first part of my interview with Dr. Frits Byron Soepyan. We hope you'll join us for part 2.
Thank you for joining us on Climate Debrief. Executive producer is Angela Wheeler. Producers, Ethan Audie and Scott Wheeler. You can find more episodes of Climate Debrief at co2coalition.org.